AI can solve most math problems and is getting really good at research too. So, what's the point of students even coming to our math classes? Welcome everyone to Math in Higher Ed with Jason Barnett. I'm a math professor at a community college in Washington State, and we are going to close the regular season with kind of how we started it. We started this season by talking about what is the point of math homework. We have to know what we want students to get out of math homework so that we can design the math homework appropriately and so that we can share with them the reason why, because students and everybody does a lot better when they know why they're doing something. And so we're going to close the season kind of symmetrically on a much bigger scale of, okay, why should students even take a math class? Or like, what's the point of a math class? What should students get out of it? And we're going to talk about that for all the same reasons of we need to know the answer to that so that we can design appropriately and so that we can answer any questions that our students might have along the way and even answer them before they ask them sometimes. Okay, so this definitely impacts course design a lot, right? We need to be thinking about things when we design our courses. Like, yes, we have outlines or curricula topics that we have to cover, but how we cover them, how we assess them, how we teach things, how we do all of that really depends on what our goals are for our students. What do we actually want our students to come away from? Do I want my students to come away from my trigonometry course having just memorized the unit circle and being able to use that memorization to evaluate any trig function by hand? No, absolutely not. I would not be happy with that. I would want my students to kind of understand how trigonometry works, how you can use special triangles to evaluate trig functions, because you're kind of understanding of like how trig functions work, right? Like that conceptual understanding is what I want more than, being able to calculate other things. But regardless of what the answer is for you, you need to have an answer so that you can design your courses appropriately. And again, that's going to be very important so students can actually come away with something meaningful. What that meaningful thing is going to depend on who you are compared to me, compared to you. And I want to close this section by saying that this is not anything new, right? I'm talking about this podcast episode kind of in the framework of like, oh, AI can do all these things. Well, how much do we actually have to do by hand? Well, that's not new. Technology has been always changing. We talk more about this later as well. Calculators are a thing. And then we were told you won't always have a calculator in your pocket. And then we did always have our calculators in a pocket. And now we have so much more. So that's where we're going in this episode. And that's why this matters to talk about. So we're going to start this next section by talking about what are some common answers to things that professors want students to get out of a math class. So one of the very common answers that I've always heard a lot is the critical thinking aspect, right? It's less of that our students are learning math and more that our students are learning thinking. This is also brought up when students ask, like, when am I ever going to use this? Why do I have to learn factoring? And well, I think you maybe shouldn't be learning factoring if you're just a regular college student. But anyway, that's beside the point, right? This is a common answer. Students should learn how to critical think. We can teach critical thinking in a math class. We can just teach problem solving. We can teach students how to see a big problem and break it down into smaller problems. We can teach them how to follow logical steps and flows. These are all very common answers to why students should be in a math class. And I don't think any of this is defeated by the fact that AI exists and is very accessible. So if these answers are your answers from before, I think they still hold a lot of water right now. Another common answer is like saying that math is everywhere, right? Like math is in cooking, math is in your money, math is in your I don't know, create your gardening. All right, these are all common things. I think this is becoming a little bit more hollow of an answer. I think many people don't have any issue just asking their phone, asking AI, asking Google, whatever, right? This is not super new of like, oh, what Like, convert this for me. Or, what dimensions of garden bed should I use? Or, how much mulch should I buy? All these things that we give as very common answers for like why students should be learning math. I think technology is very good at answering some of these things. Another kind of weakness to the math is everywhere thing is that we tend to teach a lot of students college algebra and pre-calculus. This is changing, which is very good. But historically, kind of the standard was for a student to take college algebra or pre-calculus class, very algebra-focused classes teaching students things like factoring or simplifying rational expressions, the quadratic formula, and maybe they'll learn this in high school too. But like all of these algebra things, those are everywhere in a sense. If you're me, you see these problems everywhere and you use algebra all the time, you factor all the time, you do all this nonsense all the time. But the average college student is not going to use any of those skills in their day-to-day life. Some people will, again, I do, but the average person's not. And I do think that there's too many people who are taking college algebra and pre-calculus and stuff like that. So I think financial math is definitely one of the reasons where math is everywhere that we should definitely teach more of. We should put that more into our STEM classes. We should put that more in other classes as well. But that is something that we're already doing, which is good. So those are some common answers. Two more common answers that I think are really important now in this age of AI is knowing how to ask the right questions is a very, very important skill. And if you don't have knowledge, you don't know enough to ask the right kinds of questions. Like for example, like if I'm trying to fix something in my computer, I've got a pretty good baseline for how computers, well, not how they work, but a pretty good baseline for how computers are assembled, like what the different pieces do. Like I know what the inside of my computer looks like. I know what things look like. So I feel like I'd be pretty good at asking questions. Like I'm not an expert. I need to ask a lot of questions. I need things explained to me, but I know enough that I can ask maybe the right questions. Whereas if I needed to replace something in my car, I would need so much more. And I wouldn't even be able to know where to start. I wouldn't be able to ask the right questions. If I gave like a summary of things, I'd get, like a bunch of different options. I wouldn't know which one of these options is probably the case. I wouldn't necessarily know what data to include. It'd be so much harder for me because I don't have that foundation. And I think we want students to get enough of a conceptual understanding and enough of a foundation that they are equipped to ask the right kinds of questions to AI, to other people, who knows. And then like just also asking the right questions in terms of like information literacy. When you hear a mathematical claim, maybe by your boss, maybe by your company, maybe by an advertisement, you should know enough math to be able to ask the right questions. If you hear a statistic, think, well, how is that statistic gathered? Who paid for this data? Who paid for this study? Or if your company makes a claim of something they're doing for cost saving measures, you go, wait, hold on, that doesn't mathematically check out. Like what's going on here? Being able to know enough to ask the right questions is really important. And as a result, another important thing that's really pretty much the same thing is we should know how to use tools effectively. And we need some level of conceptual understanding. We need some level of foundational learning and knowledge of the material so that we can use AI effectively, so that we can use software effectively. Again, like I was just saying, if I used AI to try to fix my car, I would have so many problems, so many problems, because I just don't have the minimum. I'm missing too many pieces. And it can't do everything for you. You need to know some baseline. Finally, this really depends on what student you are, what track you're in, what major you're in, what pathway you're in, whatever word you're going to say. It really depends. How this works for a stats student is going to be very different from how this works for like a liberal arts student, which is going to be very different from a STEM student. We're all going to want all of those students And I'm sure there's other groups as well that are distinct to come away with something different. I mentioned before that this isn't really anything new. And again, it's not, right? Calculators came out and then doing number crunching by hand, doing like a bunch of calculations by hand or in your head, it became way less important. And still, I would say we need to be able to do it to some extent, just not as much as before. And then graphing tools came out. I remember when I was in high school, everyone had to learn how to use a graphing calculator. And they were expensive and they weren't that good, but they were better than other things. And so it was kind of cool. And then, graphing became less important. Why do we have to graph things by hand? We have this calculator that can do it. But you're not going to always have a calculator, but now we do always have a calculator. And and then online solvers came out. You can just type some things into an online solver about a triangle or a differential equation, Wolfram Alpha, all that stuff came out. And you could do that by hand. But still, there was like some conceptual reasons why you might want to do it. And now we have AI. So the point is that in mathematics, we have been dealing with this for a long time. Technology always grows. And it makes it easier, lowers the barrier of entry as well. It makes it easier to answer problems that get more and more complicated. So it can solve better problems and we can do it more easily. And this has been going on for many, many years. And so a natural question is AI different or is it just a question of scale? And we'll address that as part of this episode as well. And I would say that even through this entire technological journey, which is not over, by the way, AI is not the last step in this journey, I don't think. But, I think there's still some value in doing things by hand. I think there's less value in doing calculations by hand now that we have calculators. I think there's less value in graphing things by hand. I think there's less value by solving a lot of problems by hand than there was before. Every advent of new technology, I think, gives less importance to doing things by hand. Now, notice I'm saying less importance. I'm not saying unimportant. I do think students should still be able to do basic calculations on paper or in their head. I do think students should be able to have some kind of understanding of how to graph things. I think there's a lot of meaning and purpose for being able to do these without technology. I never really care that much whether a student can graph something by hand, but if a student can graph something by hand, that shows me and lets them practice a lot of more important things. It requires reading graphs. It requires plugging like values into functions and making that connection between plugging in values and functions and their appearance on the graph, right? So like the skill itself is not that important, but by doing the skill, it teaches a lot of really good things along the way. And it also like knowing how to do things by hand also helps us know how things work. If we know if we can do it by hand, even if we've forgotten, but if at one point we've learned how to do something by hand, we have some kind of understanding of how it works, which really is nice because it avoids like the black box syndrome that AI is actually really bad at, notoriously bad at, even from AI researchers. Is, if we use an online calculator as an example, we plug in numbers, it gives us a number out. We don't see what's going on between us giving it the input and it giving us the output. Even if you have AI show you its reasoning, it's still somewhat of a black box because there's a lot of things going on inside that's not working very well. And so this kind of comes into play. I saw an example of this quarter, actually. A student was really frustrated. On my quizzes, they get to use a calculator for part of the quiz, but not for other parts of the quiz. And on part of the quiz, they were trying to find the tangent of pi over 2. And they didn't quite have that level of conceptual understanding necessary to know that the tangent of pi over 2 is undefined. So what they were doing is they were trying to type into the calculator and they were getting a calculator error and they were getting quite frustrated, and understandably so. Quizzes are stressful and the calculator giving you an error message is stressful. And that's where the calculator was correct, but with a little bit more understanding, you could have interpreted what that calculator was saying and stuff like that. Another advantage to doing things by hand is, kind of related, is it helps us find where things can go wrong and how small changes can lead to big results. Again, this is more of that conceptual understanding of how things work, which is really important because sometimes it's really, really necessary to know what small things are going to lead to big changes. For example, like, a standard thing I like to talk about in a statistics class when talking about like the difference between different measures of spread, such as variance or IQR, and like if you do a typo and add a 0 to a small data, like to a data set, that's going to greatly change the variance, as an example, and stuff like that. And if you know the calculations for where variance comes from, or if you know conceptually what the variance kind of represents or measures, then you do kind of see or understand how something small like a typo adding a 0 will have a big result. Whereas if you know more conceptually other similar statistical like measurements, you might know that, oh, adding a 0 won't have a big effect on this. Similar like with mean and median and stuff like that. And then something that is really kind of interesting, because it goes both ways, and we'll talk about half of the way now and half of the way later, is in this technology cycle that we're experiencing, which is always one thing into another thing, always changing how math works. With AI, many disciplines are going through this for the first time. Whereas I feel like in math, we've been experiencing this for a long time. Calculators change education. Graphing calculators change education. Online solvers change education. Desmos changed education. AI changes math education. We've been dealing with technological impacts to education for a very long time. Many people in other disciplines are kind of experiencing this all at once, whereas I feel like, as math professors, have been dealing with this incrementally over time. And so you might ask, is this qualitatively different? Some people will say yes. Some people will say no. I would actually say it's not qualitatively different. I think it's just a thing of scale of, yes, we can solve harder problems. Yes, we can do it more easily. Yes, there's lower barriers to cheating and academic dishonesty and accidental. I like to say accidental cheating a lot of times, of students accidentally cheating themselves out of learning by using AI in a way that's not very helpful to them. But so maybe it's a little qualitatively different, but I think overall, a lot of this is going to be similar to the things that we've dealt with. And we just have to, again, go back and say, what do I want my students to be learning? What do I want my students to come away with? And if we have those answers for ourselves as our guiding principles, then we're going to be much more effective. And no matter what the technological changes of the future have in store for us, we'll be able to work with those. Okay, so I mentioned that, I gave some common answers for what we want students to come away with in our math classes. Well, another thing that I wanted to address more fully is that this really does depend on student. It depends on what pathway they're in, what major area of study, whatever you want to call it. So let's talk briefly about that. We'll start with the easier ones. The easiest is like a stats student, I think. Someone who's taking a statistics class, maybe they're going into social science, or maybe they just need statistics for some, like, just as a math class. I think stats has a very easy answer for what's the point. And small disclaimer, I don't think stats should be under the umbrella of mathematics. I think it's the same level of applied as like physics or engineering. But in many community colleges, such as the one I work in, it's under math. So I teach it, but I'm not a statistician. I just teach intro stats, and I do think stats is a different beast. But I think stats is arguably the most important math class anybody can take, math student or not. It teaches a lot of information literacy. I talked about this earlier, asking the right questions. If you see a claim or a study somewhere, polling results, right, is huge. And then just like curiosity and awareness of the things that we're reading. Like, so many studies are done, so many statistics are cited. And if you just have like an introductory level, you're not an expert, but hopefully you have some kind of basis for asking questions. And again, like that basis for skepticism, that basis for asking questions, I think is the most important, one of the most important things for learning math in general. You might be teaching students in a liberal arts math class. Maybe you're teaching like a math and society course or math for liberal arts. These kinds of classes are usually very, very light, very, very surface level overviews of many different topics. A lot of times they cover like probability and statistics or financial math, but very basic financial math. They could talk about like voting math, basic logic, basic graph theory. These are all very cool things, these classes, which again, you're never going into depth on any of these. These are all like 1 or 2 weeks for each of those topics. But I think a very natural goal if you're teaching a class like that is just to get students excited, just to get students to see where the math is, kind of like stats in a way of like, you're not going to teach someone to be an expert on voting math. You're not going to teach someone to be an expert in financial math when you just talk about compound interest for a week or whatever you're talking about, or like budgeting or amortization tables, who knows. But you're going to give them the tools to say, oh, there's something over there. My buddy is buying a car, or I'm buying a car. I don't remember the math. I never learned the math that much, but I remember, I remember some basics like, oh, the interest rate is going to mean a lot more if it's a longer term loan, or, the more I can put on down right now, it's going to have a huge impact on the interest I have to pay. Or, oh, wow, this interest rate's pretty low. It's not that far from inflation. Or, I can use an online calculator to find out what my different interest payments would look like. Nobody's coming away from this math class doing all these calculations by hand, but they're being aware of the math that is out there, and then they can find calculators and ask some questions. And so that can be a very good outcome to look for in maybe a liberal arts math class. Get students excited about math and show them different places where it appears and give them like the knowledge that they can go look for things, basically. And I think that we'll close this section with the hardest group, and that really is like the future engineers, mathematicians, applied mathematicians, like all of our STEM math classes. I think is the hardest group to decide what we want them to come away with. I think my biggest answer for this group is, again, going back earlier, they need to know how to ask the right questions. They need to know how to use AI effectively. I do think AI is transforming these jobs heavily, and I think it will continue to do so. So again, how much importance do we place on calculating and solving? Probably not as much as we used to, but there's still going to be some level of that. And the really important thing, I think, is that foundational conceptual understanding so they can ask questions and use AI effectively. And then as a kind of side note here, I think a lot of times we think, oh yeah, AI is really good at solving these problems, or like, oh, look at this model that solved this really cool research problem. This is all, we live in a very interesting world right now. The AI is accelerating really fast, and data centers are sprouting up everywhere, and people hate data centers, and there's still not enough compute. There's not enough data centers for every company to do what they want. It's very, very, very expensive as well. People are unhappy. Like, no, it's so expensive. The AI companies are simultaneously not really profitable, but also like other companies are burning through their AI token budgets so quickly. I just read a New York Times article the other day of tech companies like burning through their whole annual budget in like 2 months for AI, and like limiting employee AI usage. They used to try to maximize it. It's just too expensive. So all of this is to say that with infinite compute, we can get very good answers to very complicated math problems, but I think we don't have infinite compute. We don't have infinite space. I don't think people want more data centers. I don't think people like a lot of how AI is changing the world. And I think that's going to be the case for a little bit. It's just a personal guess. No, I don't know what the future is going to bring, but I don't see data centers in space anytime soon. And so I think There's not an infinite amount of this stuff, and the models are only getting better, which means things are only getting more expensive. So take that with a grain of salt. The last section of this podcast episode that I really want to talk about is somewhat of an idealistic afterthought, and it has to do with how we measure value. We live in a, I'm talking about like what do we want students to come away with in a math class? And we live in a society that tends to put a lot of like monetary value on things. Like they put value on things based on what they can do for us, they can do for society. Something has value if it gives us money. Something has value if it gives us security. Something has value if it gives jobs. That's kind of the society that we live in, at least in a lot of Western society right now. And so you might say, well, if AI can do all these things, what value is there in learning mathematics? And I just want to encourage everyone that whenever possible, we should really remind students that there is joy in learning. There is joy in understanding something, and not just math, but anything, right? I don't think something has to do something for you to have value. Is ironically, right? People in the humanities have been talking about this for all, like this has been, the humanities departments have been the butt of jokes for so long about like, oh, you got a humanities degree? Oh, how is it working at McDonald's? like stuff like that. And I think it's funny that the shoe's kind of on the other foot now, is that mathematicians to a lot of extent are becoming this thing of like, yeah, AI can do math. So what do we need mathematicians for? And again, I do think there is a lot of joy in understanding and fun in learning. And I think there's a lot of value in just knowing how the world works, and math describes how the world works. So I think encouraging like creativity and curiosity and knowledge for its own sake, I think is pretty important. We should share that with our students. And again, not just tell them, model it, get excited about math. I think there's a lot of really exciting things here. So that's pretty much it. We'll just close. This is the last episode for the regular season 1. As a reminder, we are ending this season how we started it. We started by talking about homework and designing homework assignments. You have to know what you want students to get out of a homework assignment in order to make a good homework assignment, and so that they know why they're doing homework assignments. Similarly, this episode's all about, we have to know why students are even taking a math class. What should they get out of it? We don't know what they're getting out of a math class. They're not going to know either, and we're not going to be able to design an effective math class. I might do some more, like some bonus episodes with some interviews or some other people, or if there's any bonus things I want to add, I might do it season 2. Might start a new podcast targeted not towards math professors, but I might start a new podcast targeted towards math students. I think that could be really fun. But again, this is the last regular episode of season 1 at least. So appreciate it, everyone who's listened to some or all of the episodes. And thank you for coming on this journey with me. It really has been a journey, because the podcast itself is a lot of discovery in my own learning, like similar to teaching, where once we organize our thoughts and we talk through them and we explain them, we learn a lot along the way. And that's been one of the primary reasons why I wanted to have this podcast. So as a reminder, my contact information is always in the episode description, so you can check that out, make a comment, or shoot me an email. And I'd love to hear any feedback, things you liked, things you wanted to see more of, things you'd like to see in the future. But that's it for me. So thank you everyone for listening, and I hope you have a good rest of your day, night, wherever you are. Bye-bye.